So we're going to talk about while, for, and do loops. We're not going to talk about the advanced for loop yet, but we'll get to that later. We'll talk about some looping algorithms and some other fun stuff. So basically, you guys know what a loop is. It's part of a program repeated over and over until a goal is reached. Good for repeated steps, processing input, compiling many data items, and basically anytime you need to repeat yourself. The while loop is the fundamental one. You put 10,000 in a bank that earns 5% per year. How many years does it take to double the original investment? Well, the algorithm is pretty simple. Start with a year value of 0, column for the interest, repeat the following. Add 1 to the year value. Compute the interest as balance times 0.5 if you use 5%. Add the interest to the balance, and keep going until you're done, and then report the final answer. Pretty straightforward. If there's any questions on that algorithm, let's see. Statements in computer science are executed while a condition is true in the while loop. In the do loop, it's true, but it's at the end. And the basic format is while condition, which is a Boolean condition like we talked about before, statements. As long as this is true, the while loop will execute. Here's a very simple example. We're adding 1 to the year. We're going to do it while the balance is less than our target. Now, there is a possibility here is what if balance never gets to target? You're going to get stuck in an infinite loop. That's a bad thing. Here's a basic flow chart. And here's the syntax breakdown. One of the biggest things that often catches you is less than or equal. You need to think through which one you should be using, because otherwise you'll end up going one too far or one not far enough, and those are a pain in the butt to debug. If you declare a variable in the loop, it is created each iteration, and it doesn't exist outside the loop, so you have to be careful about that. If you use interest out here, it's not, you're going to get an error. That doesn't hold true in languages like JavaScript, where it actually only has limited scoping. Investment for loop. So here's basically, you step through while the condition is true. You run our calculation. We come back. Is our condition still true? Yes. Which, by the way, this condition is called an invariant. Whoops. Keep stepping through until it's no longer true, and then you drop out and do what comes after it. So here's some examples. This is a simple counting loop, basically, that sums up the numbers as you go. This is an example of an infinite loop, because sum is going the wrong way. This does nothing. Because we're starting it off with the condition already violated. What is this example? Oh, yeah. I don't know what they were thinking here. Sum 0 is never going to be greater than 10. And, oops. And this one is not going to do anything because, and doesn't end, because by putting this semicolon here, you've essentially created a while loop with one statement in it, and that's that semicolon, so nothing's ever going to change with sum, so you're stuck. So common errors, infinite loops. If you don't update your control variable, you're screwed. Here we don't update years, so you're not going anywhere. Going the wrong way. It's run forever. You'll have to Control-Alt-C the program, kill it in some other fashion. No fun. Off by one error. Loop executes one too few or one too many times. And so the question is, does the year start at 0 or 1? Well, if we want to, if we start at 0, we will go n minus 1 times. So should the test be less than or equal? So look at a scenario with simple values. Balance of 100, interest rate of 50%. After 1 year, the balance is 150. After year 2, it's 225 or over 200. So the investment doubled after 2 years. Loop executed 2 times incrementing years each time. The year must start at 0, not at 1, otherwise you'll be screwed. So use less than and not less than equal. Don't just plug and chug numbers until it works. Actually think through and figure out the problem. So the for loop is it's a simplified notation for a counting loop. So basically take the initialization, put it in the first part of the for, your Boolean condition in the middle, and then your increment of the counter on the end. Use a for loop when the variable runs from a start to an ending value. Now you can do other things around it, but you probably shouldn't. So the initialization happens exactly 1 time. This is checked each time you hit the start of the iteration, and then this is updated after each iteration. Pretty basic. It's literally the same as in C++. Shouldn't be a shocker to you. So the update gets executed after each iteration, and it's pretty straightforward till you get to the end. You can make a for loop count down instead of up, or by 2s or whatever. You can do whatever you want as long as you create a condition that terminates. If you define it in the header, it's not going to exist here, but you can always define it outside of the loop, and then it would still exist. So to go through all the characters in a string, you go from 1 to 0 to the length of the string, less than the length string, grab the character and do whatever you want. So this is an example of being able to make your code variable based on the length of a string. Use a for loop because the variable starts at 1 and moves in constant increments. Pretty straightforward. Again, this this looks just like the while loop. The only difference being it's in a more syntactically convenient form. Here's some examples. Loop executes 6 times because of the less than or equal. Here we go, we're going down. We're going to go by 2s. This one is going to be infinite because you're going by 2s but starting at 0, so you're never going to hit 9. So if you use less than or equal, that'll help you get around that. You can do whatever you want for doubling I or changing I. Yeah, here you just run through the whole string. So there's the front direction and back direction. The do loop is the only difference between a do loop and a while loop is a do loop is guaranteed to execute at least once. And the condition is at the end. So you do it while this is true. It's the same thing as taking the insides, putting it on top, and using a while loop. I can't remember the last time I used a do loop. I tend almost to never use them. But the check is at the bottom here. That's the big difference. So a sentinel value denotes the end of a data set, but it's not part of the data. It's a special magical value. For example, if 0 can't be a valid data, then wait until you get a 0 to stop. If 0 is valid but can't be negative, wait till you get -1. To compute the average of a set of salaries, for example, use -1 to indicate termination. Inside the loop, read the input. If it's not -1, keep going until it's -1. Then keep going. Now, the one thing you got to make sure to do is on the initial value, it has to be something other than -1, or else you're going to screw it up. Here's a good example. Here is the example. Basically, we are going to read in a number, and while it is, while it doesn't equal -1, we're going to get the next value and keep going until we are done. We get a -1, and then we print the average as we've gone. So using a Boolean variable to control a loop, you can actually set the variable outside and then change it on the inside. I personally kind of hate this. Again, it's kind of a classic structured programming way of doing things, but I think it's inelegant. It kind of shows kind of a lack of understanding of the logic of your code. That said, I do know some programmers who insist on doing it that way too. So when any number can be an acceptable input, you might want to use a sentinel that's not a number. And for example, has next double will return false because if you enter a letter, and so that'll bomb you out of the loop. Sometimes there are conditions that can only be evaluated in the middle of the loop. So you can use a Boolean variable to get you out of that, or you can use a break statement that'll get you out of there. So you say while something, while true, blah, 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 if input equals Q, break. You see a lot of people do stuff like this, combining an assignment statement and a test. Now think about this for a second. Input equals in.next, we're reading it, we're getting the result, and we're comparing it all in one loop. What do you guys think about that? I mean, my opinion is you can do it. That doesn't necessarily mean you should do it. I think it's an opportunity for sloppiness. Or you can just jump out of loop in the middle using a return if you're in a method. So some common loop algorithms. Some keep a running total. As you go, you keep adding in the next value. An average, you count how many values you have and divide by it. Just basic math. You know, you want to count matches. Count how many words the input have at most 3 letters. Find the first match. That's basically a search through. Keep asking the user to enter a positive value until the user provides a correct input. So basically while we're waiting for something. To find the largest value, update the largest value seen so far whenever you see a large one. This one's kind of useful. It basically gives you the idea of a trailing pointer. So you start with the largest value as the first value, and anytime you get a bigger one, you replace it. Similarly with smaller, you do smaller one. Now this requires there to be at least one input. Comparing values. So we look at a value, get the next. If you notice, we have input and we have previous. So before we assign, before we get the next one, we store the previous one. And this basically creates a trailing situation. You find that using this more often than not when you basically need to know a prior state of something. And I find myself using this particular concept all the time. So loops can be inside another loop. A nested loop. Now the thing about nested loops is every time you nest a loop, you are squaring the performance. So if something takes n tries to get done, if you have it in a nested loop, it's going to take n squared tries. Eventually this can cause algorithms to fail. So this monstrosity of a flowchart basically shows a nested loop, which I think that's not impressive. But here to print out the powers of x, you have your outer loop controlling the one value and the inner loop controlling the other. Oops, and here it goes. So this would print 3 rows of 4 asterisks. This would print 4 rows of 3. Lots of opportunities to screw up here, though. You know, an extra semicolon here or there. Notice that this print is aligned with this loop. This print is not. Here's some other examples. Print half a Christmas tree. Here we're using mod 2 to say whether to print a star or a dash. And here we're using a divide by 2 algorithm to see if we can print a checkerboard. So in a simulation, you use a computer to simulate an activity. You do this oftentimes with randomness by calling the random number generator. Generate a random number, create an object of the random class. And you can basically say, give me the next random integer or the next random double. So for example, if we want to die, we say, give me the next integer from, we create a random generator. Say, give me the next integer from 0 to 5, and then we add 1 because we only care about 1 to 6. And here's a little bit more code to show how you can model a die. So another example would be using the Monte Carlo method to simulate, to calculate pi. Basically, Monte Carlo usually refers to something where you use randomness to converge on a point. So if you shoot a dart into a square surrounding a circle of radius 1, you estimate pi for 4 hits to generate a random number between 1 and -1. First, we'll get the next double, and we'll say -1 plus 2r, where r is or x is between 0 and 1 is what the result will be. Basically, will put us in here. And if we average that over time, we should, in theory, approach pi. That is our advanced fun for today.